Yeah.
Thank you, sir.
Yeah. I will share with you. So I will just quickly recap what we did last time. So we started with the fact that nature follows the rule, and if you find this rule, you can use this rule for benefit of mankind. Okay, so I listed a few rules: gravity, like gravity, inertia, friction, electric resistance, so on. Okay, conservation of energy, conservation of momentum. All these are what? Rules of nature. Nature follows the rule, and we can use these rules for benefit of mankind. Okay. Okay. So as nature is following the rules, we can find out these rules and use for benefit of mankind. Okay. But if suppose nature is not following rule, there is no use of research. Okay. Please understand. Research means what? We are searching it again. Research means what? We are searching it again. Okay.
Again.
Now we'll go further. Then we saw the definition of research. So it is a systematic process. What we do, we collect the data, analyze the data. What is our purpose? To improve the understanding of particular phenomena. And for research, what we need is we need some training of that subject. Okay, so anyone cannot do the training, anyone cannot do the research, provided he has to build some knowledge in that field, and then he can do the research. Then what is the motivation of research? To earn the degree, to fame, to earn money, to face the challenges. Okay. Then to make the decisions. Also for decision making, it can be helpful. Like you can make some research and you can present to the government of India for making the decision. So that can be useful for making the decision. Okay. Then it is a service to society. Then we saw what is our objective of research. First thing is to become familiar with the phenomenon. Then find the relationship.
हेलो
Yes. Hello. Hello.
हेलो हाँ
Yes. Hello. Yeah. The purpose here. Our purpose here is what?
हॅलो
Our purpose
हा
is to find the relationship.
तुमचा ह्याच्या आधी आला आणि वेगळाच नंबर कुणाचा तरी आला म्हटले गणेशच्या
Here, purpose is to, just a minute. Please understand, purpose here is to become familiar with the phenomenon. Okay. Purpose is here to become familiar with the phenomenon or to find the relationship. Like we have various relationship, like V is equals to IR, voltage is equals to current into resistance. Similar relations we can find, but nowadays the relationships may not be that for every phenomenon. Simple relationship may be complicated. Find the frequency of occurrence or to find the optimum solution. So this can be your, you can say, PhD topic. Then I explain what background we need for research. I given the example. Then we saw independent, dependent parameters. Then we saw the characteristics of the research. Important characteristic is that it is controlled, rigorous, systematic, valid, verifiable, and empirical. It is empirical. This is a very important characteristic. It is not imaginary. Okay. Now we'll start today's lecture at this point. That is the steps in the research. Steps in the research. So I will just try to make it yeah. So I'll go to the, yeah. Now we'll see the steps in the research. Can you see my screen? Can you see my screen?
Yes, it is, sir.
Yeah.
Yes, sir.
Yes.
So whatever presentation I have given, it is related to my research. So instead of just giving the general, I have given some with examples. Okay. So our research start with the problem definition. We have to define the research problem. Then we have to define the objective. Then we have to design the research, collect the data, do the analysis. After analysis, interpret the results, and then validation of result. So we'll see one by one steps in the research. So our research start with the research problem. That is, we have to define the problem. Okay. Please understand why we say problem, because this is a question in our mind that we have to solve after conducting the research. Okay. So we have to define the problem. When we want to define the problem, we'll take separate lecture on the research problem. So I will not describe here again, but I will say it is very important step in the research that you have to define the research problem. When we define the research problem, we have to clearly define the problem with its limit or boundary. Please understand. It should not be unclear title. Okay, it should be clear title, and from that you should get clear idea what you have done, what you are going to do. Okay. So I have given example. You have to clearly define the problem. Study the pressure drop and heat transfer enhancement with 90-degree revs at the Reynolds number from 10,000 to 1 lakh in the square duct. I have clearly defined the problem. So I want to do the research in the square duct. So in that square duct, there will be, I will just switch on the marker. Okay. So I will just use the marker here. So marker I will use. Okay. So I want to use one square duct, and I will allow the air to pass through this. This is a heated duct. And inside that, I will use some ribs to disturb the flow and create the heat transfer enhancement. Okay. So I'll do the heat transfer enhancement. I will use this type of ribs, 90-degree ribs. Then I will use the flow in a such way that Reynolds number is from 10,000 to the 1 lakh. Okay. So we have to be very clear in defining the research. What you want to do, what will be the limit. Like I clearly mentioned that limit for Reynolds number is 10,000 to 1 lakh. I will use this rib. There are different types of ribs. I will study the pressure drop and heat transfer. So I have clearly mentioned. So there is no ambiguity. Okay. Because this will guide you for the further research. Okay. Then once you define the problem, you have to define the objectives. So we have to ask some questions, research questions, like what is your purpose? What is purpose of doing this research? You have to clearly define your purpose of doing this research. So what I'm doing here research, I'm doing the research in a square duct. There will be flow of air and the duct will be heated, and I want to study the heat transfer in that duct. Okay. So what is my purpose here? My purpose is to evaluate the heat transfer and fluid mechanics performance. Evaluate the performance. So then next question we have to put, we have to ask ourselves these questions and then answer the questions. Okay. Like next question comes, how will you do this? Whether it will be experimental, whether it will be numerical, or whether it will be analytical, or combination of this. Okay. Then next question, is the required facility available at your place? So you have to answer either yes or no. If it is a no, then we have to create that, or you have to create that, or you have to search the facility. Okay. If it is yes, then we have to see where you will do this. Then we'll do this in the heat transfer lab or computer lab if it is computational work. If experimental setup not available, we need to create the setup. So clearly, we have to define the objective in terms of question answer. Okay. We clearly define the objectives in terms of question answers. Now we have to also decide the boundary or the scope of the research, that we have to limit the research. Okay. Please understand, our research is conducted in the limited period. We cannot spend for PhD, we cannot spend 10 years. Okay, we have to finish it in the 2-3 years. Okay, so we have to define the boundary of the study in terms of time, in terms of money, in terms of the study. Okay, so we have to give the research should not overrun in terms of time and money. Like I mentioned, the scope of master's program research and PhD program research is different. Master's research program you need to finish in 6 months, but PhD program you need to finish in 2-3 years. Okay, the amount of volume of work in the PhD work must be very, very big as compared to the master's work. So this is called as scope in terms of time, in terms of the volume of the work. Okay. The same thing we have to do in the research. We have to clearly define the REEBs. So we have to clearly define the limit, like in most of studies. So why I fix this 10,000 to 1 lakh? I search the papers and mostly have done the work from 10,000 to 80,000. So it is always better to go little high, so that if as the time there is continuous development in technology, we go with the higher and higher velocity. So that we have to also take into the account. Now this is about objectives. We have to clearly define the objective. Then comes research design. Please understand, we have to design the research. Okay, no, directly do not start that. You have to plan that, design that, and then we start. Okay. In the research design, first you select the research approach. Like whether you want to do the experimental, numerical, or analytical work, or the combination. Okay. Please understand, nowadays people not only rely on one approach. Like if they are doing the experimental, few work they will do for numerical. If they are doing numerical, they will do a few work for experimental. So it is a combination. Okay. Nowadays, no one is using one single approach. Okay. So you have to use combinations. Then next is design of sampling plan. So when we take the readings, we have to take the enough number of readings, okay, so that our regression analysis, that is curve fitting, is successful. Okay. So if you take less number of readings, your curve fitting will not be good, or we can say accurate. So what we do, we have to take maybe minimum, not less, we can say minimum 6 readings, okay, to have some good curve fitting. But in research, we generally take many readings, okay, because 5, 6 are not enough. So in regression analysis, what we do is we find the relationship between dependent and independent parameter. I explained last time what is a dependent and independent parameter. Independent parameter is parameter which affect the dependent parameter. Okay. So if you take enough number of readings, then and then we'll get the clear relationship. Okay. We'll be able to visualize in the graph clear relation between the dependent and independent parameter. So in this respect, we have to design the sampling plan. So let's just move to the next slide. Then you design the experiment. First task that you have to do is we have to identify dependent variable. What is the first step? You identify the dependent variable. Like I gave the example in the heat transfer, we say Nusselt number or friction factor as dependent parameter. Please understand. What is the first step? You have to find the dependent parameter. Okay. Now for each dependent parameter, you find out the independent parameter. What are the independent parameter? The parameter which affect the dependent parameter. Okay. For each dependent parameter, you find the parameter that will affect. That is called as independent parameter. Okay. Now, we have to decide the experimental step with one factor random. So what I have to do is, suppose I have 5 independent parameters. Out of that, what I will do? One parameter I will make random. Random is it is allowed to vary, and remaining 4, what I do, I keep constant. Why I keep constant? That is called as control condition. That is called as what? Control condition. Okay. That is called as control condition. Now for each random factor fixed, okay. Once you decided, okay, fixed means what? Once you decided one random factor, okay, then for that random factor, suppose I decided factor number 1 as a random, then we have to decide is steps. Like suppose it is varying from 10 to 100. Suppose we selected one independent parameter. Now its study range is from 10 to 100. Okay. Then what we have to do is we have to decide the steps. Okay. Suppose I want to vary it from 10 to 100. Suppose I want to take 10 readings. So what I will do? 100 minus 10 divided by 10. So what is the steps is here? 9. So I have to vary this parameter in the steps of 9. Okay. So that I can reach from 10, 19 like this up to 100. Up to 100. Okay. So this approach is not only related to experiment, but this is also applicable to the numerical research. Please understand. This is not only related to the experiment, but also numerical approach. In the numerical approach also, we have to do the same way. We have to see what is the range of that particular independent parameter, and then we decide the steps. We have to vary in the steps. Okay, for each step, you have to take the reading. So in experimental design, we must also design the measurement system. Please understand, this is very important for the research. For experimental design, we have to design the measurement system. Okay. Why we design this measurement system? So whatever result we have must be accurate to the acceptable level. Must be accurate to the acceptable level. That we'll see the examples in today's lecture also. Okay. So that is our purpose to design the measurement system. For each case, we must calculate uncertainty. Okay. For each case, we must calculate uncertainty. Okay. So if desired accuracy is not achieved, then we must select the high accuracy instrument. Please understand, we have to select the instrument based on our accuracy requirement. Do not go directly to the very precise instrument. Okay. Because it is more precise instrument, it will be more costly. But see whether we really require that. Okay. That is my point here. Okay. So if you are not getting desired accuracy, then and then we have to go for more accurate instrument. Okay. This is about designing the experiment. Then single sample data and multi-sample data. So we'll see here. Here uncertainty may not be discovered by repetition. Only we take the one reading, okay? Single sample data. In multi-sample data, we take many readings. Here, uncertainty may be discovered by repetition. Once we repeat again and again, in multi-sample data, we can calculate the uncertainty. But in multi-sample data, it is difficult and costly to have repetition in the experiments. Okay. Hence, we must able to work with the single sample data. Okay. In the multi-sample data, what happens? Same input is read again and again. So we can find out the uncertainty. Known input is given and we measure it again and again. Okay. But in single sample data, it is a single reading, so we don't have anything to compare. Okay. So experimenter must know about the possible errors. You can say uncertainty in the dependent variable. Okay, that will take example today. He must know the possible errors or uncertainty in the dependent variable. Dependent variable is calculated from one or more independent variable measured in the experiment. Okay, that I will explain. First, we have to find uncertainty in the independent parameter. From that, you can calculate uncertainty in the dependent parameter. Okay. So each independent parameter will have its own error or uncertainty. There will be uncertainty in each parameter. Okay. Now we'll see that uncertainty calculation. Please understand uncertainty calculation. So you'll find in the reference, this uncertainty analysis calculation was given by scientists called as Klein and McClintock. Okay. So uncertainty in the R, where R is the dependent variable. Please understand. R is what? Dependent variable. And omega is what? Uncertainty, error we can say. Uncertainty in the R is given by this equation, where X1, X2, X3 are what? Independent variable, and capital R is dependent variable. Okay. So we calculate uncertainty in the dependent variable R by this formula, square root of del R by del X1. So we have to partially differentiate R with respect to X1, then partially differentiate R with the X2, then partial differentiate R with the X3 like this. When you take the multiply that with the omega 1. Omega 1 is what? Uncertainty in the X1. Here omega 2 is what? Uncertainty in the X2. Omega 3 is uncertainty in X3. Omega 4 is uncertainty in the X4. Like this formula we have to use. So once you find uncertainty in the independent parameters, and then you take the derivative of R with respect to that variable, partially derivative, then we can find the uncertainty in the dependent variable. Okay. So this is the formula. We'll also take one example so that you will understand here. Okay. Now suppose this is one equation, relation between the dependent variable and independent variable is given by this formula. It is a product function. R is equals to x1 raised to a1, x2 raised to a2, x3 raised to a3, like this. R is dependent parameter, and this x1, x2, x3 are the independent parameter. Then we can write the formula. Uncertainty of R divided by R is equals to square root of summation of AI. AI is what? Power of that variables into omega. Omega is what? Uncertainty in the independent variable x1 xi divided by xi, like this. Okay. So if you calculate, you can get the uncertainty in the R from the uncertainty in the xi. Okay. So it is required, okay, even though you may find it little difficult to understand at this stage, but you have to use this in your thesis. Now, like here, I have given one simple example from my thesis. Suppose you want to find the mass flow rate, okay. So mass flow rate in terms depends on coefficient of discharge, parameter Y, parameter M, diameter of throat, density, delta P. So it is a product function. So I could write uncertainty of mass divided by mass is square root of uncertainty of CD into the power of CD is what? 1. So it is 1 is there. So you'll not find that, divided by CD square plus uncertainty in M divided by M. Power of M is 1. So it's 1 only. Then comes diameter, the diameter square. So it is uncertainty D. So it is square. So it becomes what? 2. Okay, 2 square is 4. So it comes out and 2 square become 4. Okay, divided by diameter, like this. Okay. So like this, you have to take, you have to write the formula, put the values, and calculate. Now we'll see putting the values, what happens. So these are the various uncertainties, like in manometer, this 0.5 mm. In the diameter measurement of throat, it is 0.1 mm. Error in density measurement 0.34. And so we have to find the relative error. So relative error in the manometer reading is 8.3%. Okay. Relative error is what? 8.3%. So I'll just move to next slide. Similarly, if you calculate in percentage, actually we have to use in the percentage, okay? So like uncertainty divided by that value. So it is what becomes percentage, okay? It becomes what? Percentage. So once you see these brackets, so you'll find that this omega p is a very large value, 8 square. It is almost 56 divided by 4. So it is very big value. Okay. So please understand why I was telling you to do calculations, uncertainty calculation before start of experiment, to know that which will give the more error. Please understand here. So here pressure measurement is giving the more error. So what is the square of 8? Can anyone tell what is square of 8? Yes, what is the square of 8? Yes. What is square of 8? Yes. If you divide by 4, it is very large value. Okay. It is very large value. Okay. So 8 square is almost 56 divided by 4. So you get almost 16%. So 16 is very big. Okay. So the largest value is this. Okay. So we have to, why we do uncertainty analysis at the time of instrument selection is to reduce this uncertainty so that our research become acceptable. Please understand. If you tell that your research is having very large error in measurement, no one will accept your result. Please understand. No one will accept your result. Okay, so from this, it is clear that if you use with this high error of pressure measurement, it will give very high error in mass measurement is about 6%. 6% is not acceptable. 6% error is not acceptable because then we cannot trust your conclusion because your measurement is having very, very big error. Okay, so you have to control this by controlling the uncertainty in the pressure measurement. Similarly, for additive function, there is a formula. We can use this for calculation of uncertainty. Like uncertainty in R divided by R is equal to summation of AI omega I square. And then this is the bracket square. There is square root of summation of square of summation of square of AI omega I. Okay. For the additive function like this. You have see product function. This was the additive function. Now, what is the use of this uncertainty analysis, which is very important for the research measurement? So why we do this analysis? To find the ways we can reduce the uncertainty. Because once uncertainty is very small, maybe 1 or 2%, we can accept the result. If it is more, then the variation we cannot trust. Okay, so we have to limit the uncertainty to the 1-2%. Okay, so we have to use this analysis to reduce the uncertainty. Then we can use this for selecting the appropriate measurement method. We can use this uncertainty analysis to select the instrument. Okay, so we'll see in the next. We'll take a 5 minutes break, and next session we'll use this uncertainty analysis for various purpose like selecting the uncertainty, selecting the measurement method, or selecting the instrument. Okay, so we'll join it back again in 5 minutes. Thank you.